This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI Podcast. My name is Peter Seberg. I'm your host. Today, I'm going to be talking to Andre Sagodi. He is manufacturing and innovation expert with Audi. And Andre and I are going to be talking about scaling artificial intelligence in manufacturing by example of experience gained at Audi. Hi, Andre.
Thank you, Peter. It's great to be here.
Let's start with you quickly introducing yourself to our listeners, please, Andre.
So, originally from Germany, I relocated to Hungary in early 2024, joining the site planning and vehicle production department. And I recently contributed to the launch of the Cupra Terramar and the new Audi Q3. And as Peter, as you just mentioned, we are also about to scale AI-based computer vision in manufacturing. So before that, I worked at the Audi production lab in Germany, where they explore cutting-edge technologies to push the limits of production. And the paper on AI scaling, which we are going to talk about, was developed during that time. So alongside my role at Audi, I had been a part-time doctoral researcher in information management at the University of St. Gallen.
Sounds great. And congratulations on having been awarded the IAS Senior Scholar Best IAS Publications Award 2025 for exactly the paper that we're going to be kind of talking along. Okay, so you moved from, I was just asking you how to pronounce your name, and you suggested there's different ways depending on if it's the German or the Hungarian pronunciation. You already also mentioned, if I'm correct, one or two brands, sub-brands maybe. So tell us a little bit more. I will assume that the majority of our listeners will have heard about your company, Audi, but tell us a little bit more about the company, maybe specifically what they and what you do in Hungary.
All right. So first of all, thank you for mentioning the Best IS Publication Award. And that's right. And we are very delighted about that. I think it's a great recognition of our research and practice collaboration. So just to mention that one. So Audi is a global car manufacturer with more than 87,000 employees around the globe. And I am located in Győr in Hungary. We are in the site planning department for vehicle production. So we are producing the Audi Q3 and the Cupra Terramar. Yeah, in the site planning, we are actually the guys to get the processes running in production. So we are aligned to the production strategy. The current Audi production strategy is built around the 360 factory concept, which aims at efficiency, increased automation, and innovation technologies to deliver premium car quality at scale.
Okay, that sounds good. And that makes me understand why you have been writing together with, there's 3-4 other names, Benjamin van Giffen, Johannes Schnitzhauer, Clemens Niehues, and Jan van Broeke. There are many not easy names. You together as a team, you wrote this article, title of our today's podcast, How Audi Scales Artificial Intelligence in Manufacturing. Give us just a quick introduction on what that is about.
All right. So basically, AI has the potential to create enormous value in manufacturing. I think that's nothing new. So we're thinking about boosting efficiency, improving quality, or reducing cost. But although many companies launch AI pilots, very few actually manage to scale their solutions. So, however, the real value only appears when AI is embedded at scale in the daily operations. And that's exactly what we show using the Audi case.
Let's start with exactly that. Sounds maybe for you like maybe unnecessary question, but nevertheless, I think actually when we were with our friends in Amsterdam, we talked about scaling. That was in the environment of AI models. Maybe can you for us define what do you mean when you talk about AI scaling, AI scalability?
Yes, sure. So for me, scaling AI isn't just about technology. It's actually it's about creating an organizational capability to turn AI-based solution into business impact. So in the paper, we are distinguishing between two phases. One is innovating. So that's the phase where we explore, develop, and then in the best case, implement new solutions. And then there is scaling. So scaling is actually the phase where we exploit those solutions for exponential value. And here's the crucial point. Innovation and scaling are not the same thing. So innovation is a cycle of trying, failing, learning, and adapting. And scaling, in contrast, is a discipline of taking what works and bringing it into a broader use.
I understand. My brain brings me to what is the Gartner hype cycle? It's not like that, but maybe the feeling is like when you say innovation. So maybe you try 10 different things. The engineers try 10 different things. 9 things don't work, which means the Gartner hyper scale, it moves off the chart. And then there's this one thing, they say, oh, wow, this is great. And maybe then you or whoever is in charge of scaling comes in and say, okay, now let's see that we make this new innovative thing. How can we scale it? Is that a way to look at it?
Yeah, that's right. So I would just like to add that it's not about one-off deployments. So it's actually about building a system that can be replicated, and in our Audi case, scaled, so to say, across multiple sites. And therefore, the idea is to decouple the cost for innovating from the value it's providing, and therefore unlocking efficiencies at scale. So, and therefore, it's about designing those solutions for scalability, which is another term we are using in the paper. And scalability is, so to speak, a characteristic of the system, which is purposefully designed during the innovation stages, and later in the scaling stage, it pays off.
Right. Understood. So, in what different forms then would AI system scalability appear, generally speaking?
Well, I think we have it particularly in the implementation stage in the paper. So we're talking a lot about system architecture, so scalable architectures, automation within the AI-based system, the data labeling as well. So we have some kind of data network effects when we are labeling the images. Then by using a one model approach, we are able to use the experience from one side to inform the other side. And of course, there are also monitoring components, and we try to automate those components in order to increase efficiency.
Very good. And we're going to be going into the details of any of these later on. Now, what would be the challenges then of realizing AI, artificial intelligence, value through scaling?
I mean, scaling AI in manufacturing, I would say it sounds exciting, but there are some various AI-induced challenges, and we have carved out 3 major challenges. So I will just name them. So it's the learning requirements of AI, it's probabilistic reasoning, and it's the data processing. So just to go through, quickly go through.
Yeah, tell us a little bit more about them. Yes, right.
So first, the learning requirements, it basically means that AI needs massive and high quality data sets. So scaling means collecting and validating data across multiple sites while maintaining the data consistency and relevance. And that's also important for the labeling, for example, because experts from different sites may have a different view on the domain topic or on the problem, and they may start with a different label approach, but we will talk about this later on as well. And the second one would be the probabilistic reasoning. So AI decisions are probabilistic. I think we all know it, and it's context sensitive depending on the input data. So in some way, the performance must be safeguarded for every deployment with a robust monitoring and then adaptation if needed. So adaptation to local context. And this is kind of new. And the third would be the data processing. So especially for incumbent organizations like Audi, integrating AI into the legacy IT, then operating it and providing resources for large-scale data processing and the training of the algorithms is a major challenge or a new challenge.
Yeah, that's a great introduction. A great, let's say, well, I mean, you coming from the experience, but I believe also like a, let's call it maybe more theoretical introduction. Now, let's move then towards what you have learned then from your company Audi in practice. Maybe give us a first introduction. I think you've been using a very specific use case. Maybe you want to describe that, and along the lines of that use case, we're going to be discussing the topic of scalability in more detail.
All right. So I think this use case, it's kind of a perfect example of how scaling AI creates real world impact, especially because it tackles a seemingly unspectacular task, which is crack detection in sheet metal parts. And we will see in the course of the paper or in the course of the explanation that what makes the difference is the great execution, which brings the differentiation in this project. So imagine an industrial press shop producing millions of deep drawn sheet metal parts every year. So it's a few million parts every year, such as door panels and side panels that define the look of today's cars. And this deep drawing process runs through several forming stages, each taking only a few seconds. So we are talking about a highly productive and stable production system. And this
now these machines by itself, for those of you that have or have not seen, they are in itself very impressive, at least the first time, isn't it?
Yes, they are.
When you walk into the factory, into the industrial environment where these huge, typically huge presses are standing with a, you see them there. They typically are rather gigantic, I believe, right? Or
yeah, right. It's actually the tool changing process is like opening a garage door. So it's really, yeah.
So that in itself is very impressive, yeah, right? So that's what we're talking about, right? So these huge presses,
right,
producing then pieces that come out in the end, that in the end are going to be forming together with the structure of the car, right?
Right. So that's a highly productive system. And however, we still occasionally cracks can occur at critical points in the sheet metal due to the forming steps. And we were given a rough estimate that not one more than 1 out of 1,000 parts has a defect. So we're not talking big numbers, yet at such production volumes, even that quickly adds up to a significant number for the company. So in the past, there were manual inspections, and these inspections were just sporadic and prone to missing some defects, which were then only discovered downstream, so causing inefficiencies.
And manual means humans
at the end of the process.
Those humans, they would need to look at the complete part. Maybe they had a little bit of they know that maybe in one specific area the chance was higher of something being not correct than another, but they would have to look at each different part.
Right. So this was mainly a sporadic inspection, and so it was kind of prone to missing some defects. So later they started with conventional image analysis, which offered a better support, but still relied on pre-engineered features, which were manually configured. So using something like a grayscale analysis, for example. So these systems required frequent recalibration whenever the process conditions changed, leading to higher integration costs and maintenance costs. Yeah, and then today they are using the AI-based approach, which is actually a game changer. So to put it in a nutshell, it learns the concept of the crack from images. So it's similar to a human expert, so to speak. Therefore, it can better adapt to process changes without needing recalibration every time. And even more interesting in that case, the implementation at Audi centralizes key components to enable faster integration and scaling across multiple sites. So that's what we are going to talk about, I assume, later on.
Exactly. Very good. And that's very important. So now we've all understood what is the use case. And some of you may say, oh, well, okay, that's, oh, yeah, we've been doing that. But the point is that you started doing this a couple of years back. So why don't you tell us? I understand that you have 4 stages at your Audi AI scaling journey. Maybe just give us a top level overview of what those stages are, what they were, starting in what year?
Right. So connecting to what I've already said, scaling AI isn't a one-step process. It's actually a journey which requires designing for scalability from the outset. And there was this innovation and the scaling stage. And in the paper, we have subdivided the innovation stage into 3 parts, 3 stages, which are exploring, so finding the use case, developing the use case, mainly talking about feeding the model and data governance, and then implementing what I would consider to be the heavy lift. And later on, the scaling stage.
Okay, let's go into a little bit more detail there. As I just said, some of you may say, okay, well, that's the point is, I believe that if I understood correctly, you started this project with this use case that you just described already in 2017, right? So we're now 26. So when we talk scaling,
That's right.
yeah, but it's an important
Yeah, it's quite a while.
factor, right? I think what you're telling us is that when you scale in a global company, like in this case, Audi, part of the VW, Volkswagen organization, because that's what we're going to be talking about as well, right? It takes time, right? So let's go a little bit into the details of these different phases. So why, number one, would you have chosen? I think that's a very important question. I actually used it myself. I can already tell you when just couple of weeks back at the conference asking questions when we talked about scalability. Tell us, why would you have chosen the use case that you did? You could have chosen another use case. What would be the criteria for you, maybe for our listeners, when they're going to be thinking about the same, for which use case to choose to potentially scale into the future?
Yeah. So I think the main point at the exploring stage is that we are talking about a domain-driven project initiation. So there are those 2 perspectives, whether there's a problem pull, we have a problem in the process and we need some technology, or there's this technology push, we have a new technology and let's find out how to use it in the process. So as I already told you, recognizing defects has been a long-standing challenge in the press shop when I was comparing the different solutions. And this is quite a difficult task because these cracks vary in size, in width, and in direction. And on top of that, slight, even non-critical indentations or even oil residues can appear to be cracks. So it's hard to distinguish even for the experts whether something is a crack or it's not. And then in 2017, colleagues from the press shop attended an internal technology event where they showcased something totally different. So they were showcasing autonomous driving and AI-based traffic detection. So then the guys raised the question, if one can detect objects in traffic, why not the cracks on our sheet metal parts? And then they actually began to incubating the idea. And then they had the luck to talk to some guys from the IT and machine learning department. And then they jointly started to showcase an AI-based solution. So they started with the key question, as with any classification, can the experts confidently tell from images whether it's a crack? And then they built a prototype which went kind of viral in the company.
Very good. Maybe this viral in the company, maybe that's at least hypothetically, that is important as well. I mean, if that is your job within the planning department, if maybe the engineers will give you 10 potential use cases, and it is the team's job to say, we're going to be looking for number 3 or number 6 to potentially scale. I think you shall be looking into the future and say, if we're going to be looking at this, and one of the criteria, it's a question I have, should be that the thing that we're looking at shall not be only applied in this specific factory where you are at that moment, but shall potentially, where you are, be used around, I have no idea how many factories you have, let's say maybe 100 factories around the world. So it must have the potential to scale, to become really big. Is that logical?
Yeah, that's right. And that's actually what happened with the prototype. So it went viral in the company, and then it ignited some serious interest, even from strong stakeholders like a press shop's steering group.
Good, even better, even better, right? For those that were in charge of doing it, when it goes viral, it even is better than you or whoever does that needing to go to the other factories and convince each of the separate stakeholder makers. Now, one thing, talking about a crack, you already said that's not easy. It's even not easy for humans. So my question is, who then decides what a crack is? When is a crack a crack?
Yeah, that's a good one.
I saw something about a data labeling manual. So how does that work?
So then we're actually in the developing stage. So that's a stage 2, which is all about feeding the model and getting the ground truth of the data right. So at first, there were multiple sources of data collection. So yes, including literally fishing cracked parts out of the scrap to take reference images, as there are just a few cracks, as I already mentioned. So that's kind of the skewed data challenge in manufacturing. You don't want cracks in production, yet you need them for training. And even this step only worked because they had a strong buy-in from the factory workers, and because the problem pull was unmistakably clear. We want to resolve this issue. So workers were actively involved early on. And then they developed a centralized data labeling platform and a data annotation guide, so that every worker labels those images in the same manner. And particularly with our zero defect policy in production, edge case discussions became very essential early on. So they created this data annotation guide, which was kind of even an interesting social process with a lot of negotiation among the experts. As I told you, they are working in different shifts at different sites. So it's hard to capture the ground truth in the data. And from a machine learning standpoint, they first decided to build just one universal AI model. So there's one big model which get feeded to avoid a model zoo. So not every deployment should have an own AI model, so to speak. And they also integrated multiple quality assurance methods like consensus labeling, or they also created a reference catalog for defects.
It's very interesting. I was going to ask you, you already kind of said, in how far factory workers were involved, implying the question that, were some of them kind of afraid of, specifically those people that had been doing this quality job before. Were they sad? Were they afraid of losing what they had been doing? So in how far were factory people involved?
So they were definitely involved right from the start. I don't know in very detail, but as the problem or the project was domain driven, even the planning guys for that project were able to speak the language of the whole workforce, and they started to integrate the workforce early on. They even started with clarifying things like, what is actually AI? What does AI-based computer vision mean?
Very good. Well, why do I say very good? Because yes.
So it's kind of it's kind of a demystifying early on.
Yeah, very good. Robert and I have been going, and still do, whoever is interested. We go into factories and we tell them the complete workforce, like a 101 introduction. If it's only around midday, lunchtime, only 1.5 hours maybe. Nevertheless, that because everybody these days, and you are already now talking maybe a couple of years back, so that was very good, very important, I believe. So we're talking a little bit now in the stage 2, I believe. If we talk maybe little bit of the solution? If I say very specific question, in the end, is this a cloud edge solution? What do you choose to do?
So at first, the solution, or first to answer your question, so the algorithm runs centrally, so not on the IPC at the line, but centrally could be in a data center, depending on the site, either a local data center or a cloud. What matters most in this use case is having a central orchestration layer for the AI models. So where the model technically runs is less important. The priority is to avoid local reconfiguration whenever something changes, to just avoid this model zoo.
Very good. I'm not sure how close you still are to this very topic. Is that, and assuming that this decision was made already, then maybe a couple of years back, actually, is that possibly changing? I mean, assuming that you're still close to that topic, I mean, we do hear a lot about inference taking place on the edge, so to say. But nevertheless, as you said, maybe you still need at least like a central orchestration. Is that something that you would stay? Now, I'm moving actually already almost like after the scalability has taken place. But is that then something that you say, okay, the scalability has been taken care of, but we stay close to where still potential changes may be made for good reasons?
So the solution is still fully integrated into it's called the Volkswagen Digital Production Platform, or DPP, which is kind of the Volkswagen Group's cloud-based, standardized digital backbone for manufacturing. So it's kind of a factory cloud. In this specific use case, I don't know the very details to date, but what I can say is that, for instance, the data pre-processing and the candidate selection can be performed on the IPC if needed in such solution. And it also depends on the setup in a whole. So if you have a data heavy setup, so imagine you have to get a lot of data into the cloud, you might get an issue with the inference time of the whole system. So we are basically always using a hybrid logic, depending on the site and depending on the use case itself.
Very good. I still have many, many questions, but maybe we should be moving towards, there is a list of recommendations that you have. And then when you start sharing those recommendations, I'll jump in and ask you more specific, detailed questions. So yeah, there is this list of recommendations and actions for AI scaling. So you want to maybe give us an overview of that, or just first jump into the first one, talk about that?
Yes, sure. So based on the experience, scaling AI successfully comes down to three big moves or three recommendations. So the first would be to make AI scaling a strategic priority. So this means don't just chase pilots, focus on use cases that align to your business strategy and design for this scalability from day one. So this means prioritize scalable business problems and then deliver substantial value. For example, which also means you need to somehow align to your business strategy. So in the Audi case, AI-based quality inspection directly supports Audi's production strategy around zero defect expectations and efficiency. And another point would be to take a long-term view, or at least a longer-term view, when evaluating these business cases. This is also essential for an effective portfolio strategy we would recommend. So I think there are two questions mentioned in the paper, which are, I mean, if a non-scalable use case still delivers immediate and tangible results, then that's cool. Take the quick wins and use it to learn. If not, you need to be clear how to invest in capabilities that enable this scalability in the future. So then you're talking more about value cost considerations, about larger portfolios, and this may also influence your decisions around resource allocation and so on.
Okay. The other thing I can imagine, now that's maybe, well, I mean, there's other companies that have, I mean, you have a handful, two hands full of big brands in the Volkswagen Group. There's other listeners that may be working completely different, maybe consumer brands. Maybe there's 100 or 1,000 different brands. Now, the question for you specifically is, and I don't know enough about each of the brands, but I can imagine that again, if you say looking towards the future, you also need to be in line, in sync with the overall, in this case, the Volkswagen Group direction, which again, I don't know if that is always 100% the same for each of the brands. Let's say that potentially one of the brands is a little bit into a specific other direction than the other brands. Is that something that you need to be aware of because you want to be going for a use case that goes in a direction of which you know maybe at least 8 other brands are going to be going for as well?
Yeah, I mean, there's at first we are using this DPP, so this Volkswagen Digital Production Platform, and we are communicating with the different brands as well. In the end, it should be, at least in manufacturing, it should be quite similar problems. So what's good for Audi in terms of manufacturing or deep drawing sheet metal parts should be somehow even relevant for the other brands. And then again, we need to have kind of this discussion with the relevant stakeholders. And I mean, we can also learn from them. It's not that we have an idea and then we just have to go forward. We can also learn from them, and maybe in the end, it's a better solution for all.
Okay, first recommendation, making AI scaling a strategic priority. Which is the second one?
So the second one is to foster the collaboration and the shared ownership. I think it came clear in the beginning that the co-creation makes those solutions succeed in the real world. So you need to bring together domain experts, AI specialists, IT experts, and end users quite early on. Of course, you need the interdisciplinary teams with AI experts right from the start. In our case, experts who define that we are just using one model instead of a fragmented model landscape. And yeah, then it's important to endure and stay on it. We were just talking about 2017. So kind of like the hype cycle. After the initial hype, for example, the viral prototype, there's usually still a mountain to climb. And the use case, the success comes from doing the hard work to climb the mountain. So yeah, I think this will reveal how substantial the business problem actually is.
When you talk about collaboration is a thing between humans. You have factories all over the world. You know, if you talk scalability, does the use case that we're talking here today is, I believe, a use case that was kind of born within one of the manufacture sites in Germany, I believe. Is that typically the case? Could it be that there's going to be colleagues somewhere else in the world that come up with a great AI use case? Or would maybe you, wherever you're based in the central planning department, take care of that? And then what I was going to ask is, like, it's always this cultural things. Where's the level of AI experience in the different environments around the world?
I mean, the ideas can come from people from every factory, and we have kind of exchange with different sites. So to ensure that we can capture as many ideas as possible and evaluate them together with the other guys. But the main point I was talking about is the co-creation, particularly between specialists from different domains or AI experts, domain experts. And there's also I think it's maybe also interesting that organizations may benefit from an ambidextrous approach, which just means use both hands. So on the one hand side, they need to exploit existing capabilities, so they need to keep the production running. And on the other side, they need the freedom to experiment with new use case ideas. And at Audi in Ingolstadt, for instance, or in Neckarsulm, we have this Audi production lab where we provide the freedom to do such use case experimentations.
Very good. Dan, what is your third recommendation?
So the third one is to streamline operations. I think we've already covered that quite well. So it's about efficiency in AI operations, especially when scaling. It's key to decouple the value and the cost. So you need to build a technical backbone that enables efficient scaling. And there's also a lot of automation involved. So data pre-processing, label candidate selection, model monitoring, and streamlined data and AI pipelines. Again, automation is what keeps things maintainable.
I understand that establishing a governance framework is part of this one. Can you talk a little bit about that? I was going to ask you in the beginning when we talk governance. I think it's related to data drift. It's not good enough to just install a process, even in, as you said, I assume, let's say Ingolstadt, and you introduce it and maybe you update it in the first couple of days or weeks, and then you are happy and you move beyond this, what you said, 1 per 1,000, it moves to 1 per 10,000, 1 per 100,000, whatever the great number is. Even then, you need to stay close to your process within one factory, but even more so later on if you move the same process to another factory, right? Can you share a little bit of your experiences there?
Yes, sure. So talking about governance frameworks, this is actually 2 points. So it's one is the clear labeling guidelines. So how to name the data, how to classify it, and how to keep the labeling consistent. And the other one is also standardization of components, such as camera connectors, or to ensure seamless integration in the VW Group ecosystem. But yeah, maybe regarding the monitoring question, they also established a robust monitoring systems. So in the paper, we were talking about uncertainty pipelines and drift detection. So uncertainty pipeline means that we are looking at the model output and measure how confident the model is in its predictions, which will impact the production directly. And the low model confidence becomes or low confidence predictions become ideal candidates for further retraining. So if we see at one side that the model confidence is getting lower, we can retrain based on those selected images. And the other side would be the drift detection pipeline. So that's actually the model input, and it monitors whether the data foundation or its distribution has changed. So defects, for example, fluctuations in the production process or changes in the data acquisition. There may even summer or winter may make a difference in terms of lights.
Okay, Andre, thank you. That's great. That's really, really impressive. And what I'm thinking of, again, listening to you here for 3/4 of an hour, that what we are capable of doing, and I say we in general, in global, in an industrial environment, in this case specifically in Europe, this case Germany, but it's not explicitly and exclusively for Germany. That is not the point I'm trying to make. But we hear all the time, everywhere, we hear about AI models. We hear all about consumer and what's happening or what is not happening. And then we hear of this great scaling use case that you've been working on for so many years. And that, and I mean it in a positive sense, that you're rolling out to a global manufacturing capabilities at Volkswagen, and it's really impressive. And that is, it's almost like implicitly that's what scaling means, I believe, right? So it's somewhere realizing where there is this potential, and you made a great description. I think you said certain people started with autonomous driving and thinking, oh, if the algorithm can do A, B, maybe it can do B as well. Why don't you tell us as a close? You already mentioned you're based in Hungary yourself. Tell us a little bit more, maybe, about what it is that you or people around you do, where exactly you're based. Maybe you're looking for talent in Hungary, or maybe you know of colleagues looking for AI, industrial AI talent, and what is it specifically that you would be looking at interested people bringing?
Yes, sure. So as you mentioned, I'm based in Hungary right now. However, we are working closely together with the colleagues across the entire group, both on car projects and broader innovation initiatives. We are also in Hungary driving innovation and AI applications across our Hungarian production lines. So one concrete example would be AI-driven quality inspection in assembly, which is a project I'm leading together with my colleagues, both from Hungary and Germany.
Okay.
Of course, having scaling in mind. And yeah, regarding talents, we're seeking talents with strong technical expertise in AI and in data science, ideally combined with a deep understanding of manufacturing. I think that comes clear with this case. but also capable to blend AI with production insight. And yeah, I would say it's not only about technical skills. We also value people who collaborate across disciplines, both bringing curiosity and strategic mindset to the table to connect the dots. So yeah, depending on where you are in your career, thesis projects or internships are great entry points as well. So for the younger listeners, I think it offers a great chance to explore industrial processes and experience innovation spirit, whether in the Audi production lab or the IT or the specialist departments. So the next wave of talent will help define the factories of tomorrow. I hope so.
That sounds great. Andre, thank you very much. You, dear listener, if Andre has triggered an interest for you, I know that if I would be younger, I would certainly consider applying. I think it's really, really impressive what you're doing. And just to say in different words is like, well, you're no hidden. I mean, you are champions in itself from a brand, let's say from the consumer perspective. Most of the people know the end product of what you do at Audi and of the other brands within the Volkswagen Group. But hearing from you, listening to you of how you get there and how you are introducing artificial intelligence capabilities within the manufacturing production has been very interesting. Thank you very much, Andre.
Thank you, Peter. It was a pleasure.
Thank you. Bye-bye.
Bye-bye.